I'm Raymond Jimenez, and it's early in the morning of March 24th, 2007. I'm here documenting this Fusor run I'm about to do. Just getting ready to do my initial steps of fusion. This run in particular will not be a fusion run. I don't have the equipment yet, and we're not quite as decked out as I'd like to be in terms of safety and everything else. So that'll probably come later, but for now we'll just be doing a raw air run. What you're looking at right now is around 277 micrometers of mercury for pressure and only around 200 volts on the inner grid there. You can see to the right there is a bugle jet, which is one of the characteristics of higher pressure operation. At the moment, you can't really push the voltage any higher, or else it'll just demand more and more current, and as it demands more current, it will blow the transformer. So let's not do that. I'll put it up a little bit to show that there's sort of a star. This is still at around 200 volts, just a little bit more juice into it. Let's start the mechanical vacuum pump and see if we get to a lower pressure where things are a little more interesting. So the pump's on now. I'm just going to go ahead and open this valve here. As the pressure starts to fall nearly immediately, you can see how the plasma changes. The bugle jet becomes more sharp, and the portion becomes more defined in the middle there. Even though this isn't a fusion run, you can still see the behavior of the plasma, which is very important to note when you are actually doing fusion, because just the look of the plasma can mean everything to you. It can tell you a lot about your operating conditions. So right now we're at 24 microns mercury and falling, already at 1000 volts. So I'm just increasing the voltage here to compensate for the lowering voltages, lowering pressures rather. For this one I'll probably be going up only about to 14,000 or 50,000, depending on conditions, how far I could get up in terms of voltage. 15,000 volts, that is, which probably will lead a pressure of around 9 or 8 microns mercury. Excuse me for being a little congested. I've been sick for the past couple of weeks, so that's why my nose is totally blown. Anyway, we're at 13 microns now and 2 kilovolts. Uh, 2.5, 2.6 kilovolts and 13 microns still. Right now at the moment I'm just operating with the rotary vane mechanical pump. It's a two-stage pump that's rated at a pressure of 0.1 microns, but it'll only ever actually get to around 10. In the past I've had it get down to 7 thanks to the glow cleaning of the Fusor. It's a behavior that's innate to Fusor operation. Basically, the ions hit the outside of the metal shell, and they heat it up, which means that the gas permeates from it, outgasses it because it's heated. So once we get up into higher voltages, about 12,000 volts, the shell becomes so hot that gas load from the shell becomes a non-issue, and I have to worry about the other components in the system. Anyway, we're at 5,000 volts and 10.6 microns. Well, the only other limiting factor in my operation today is the fact that I don't have a whole lot of X-ray protection. I have a radiation detector, as you might have heard, with the clicks. It has a Geiger tube in it. However, I do not think it's actually working. I've gone up to 13,000 volts or so before, and it didn't show any increase in radiation beyond the background count, which is most definitely wrong. There was some X-ray shine through. Anyway, we're at 6.2 kilovolts right now. Star mode is beginning to appear. The rays are getting a little more defined. We're at 10 microns. increasing voltage here to match. .7 kilovolts, 7.8, and 8. Star mode's definitely becoming pretty visible here. You can see the rays just shooting out of the center there. The pulsar is becoming tighter and tighter as voltages go up. Uh, 9,000 volts now. One trick I've learned in my couple of months of Fusor operation is that if you increase the voltage rapidly, it'll heat up the outer shell so that it outgasses, and then you won't have to worry about gas load. Right now we're almost at 10 kilovolts, just increasing. We're at 10 microns. This is a pretty stable region of operation for me. I like to call it the 10-10-10 plateau. I'm at 10 kilovolts, 10 microns, and probably only around 5 milliamps, but I have run at 10 milliamps before. 11 kilovolts and 9.9 microns. Back up to 10. Anyway, with this you can see how Star Mode is really beginning to show itself. It's pretty darn distinct here. The grid at this point is already beginning to glow a little bit because of the temperature at which the ions bombard it. An interesting thing to note is that as we go up in voltage, the X-rays begin to shine through the viewport, and they start hitting the camera's CCD. And the CCD actually acts as an X-ray detector. When the X-rays whiz by it, it actually shows them as white pixels on the screen. So maybe we'll be able to see that as we increase the voltage. We're at 13 kilovolts now and 9.5 microns. Some days are pretty good for operations, some days aren't. It seems that this one is a pretty good day. I conducted a run earlier this Friday at around noon, and I wasn't able to get nearly as good of an output as it was now. We're at 13.4 kilovolts easy, and we're maybe in the first 7 minutes of our run, so that's pretty good. 13.7 kilovolts, 10 microns. 14 kilovolts. Let's see here. Just trying to regulate the pressure and voltage as best I can. I don't have a real way to control the pressure at the moment. I only have a diffusion pump in addition to my mechanical pump, to pump down to deeper vacuums than around 10 microns. However, the diffusion pump pumps all the way down to 0.01 microns, and at that sort of pressure, you can't really get any sort of useful discharge. Anyway, we're at 14.4 kilovolts, and the white pixels are beginning to show up distinct rays of X-ray shine, distinct signs of X-ray shine through. The only way I'm really protecting myself from X-ray shine through at this moment is just short exposure times and get in and out of there fast as I can. There is lead shooting coming in for me in the next Monday. It's a Saturday today, so hopefully I'll be able to run a little faster. We're at 15 kilovolts right now, 14.8 to be precise. Anyway, there's a whole bunch of white pixels there. That's X-ray shine through. 15.6 kilovolts. And I can already smell the stainless steel outer enclosure getting hot. I can smell it. Usually my Fusor can get blisteringly hot on the outside. I've touched it and it's just painful to the touch. It's pretty damn hot. We're at 9.7 microns right now and 15 kilovolts. As you can see, the radiation detector isn't actually detecting anything out of the ordinary. It's still doing regular background counts, which definitely is not right. We just had a glitch there. The DMM I'm using to monitor the voltage signal off from my high voltage supply just flashed down to 0 and positive. So we're at 16 kilovolts. This is the highest I've done in a long time. Star mode is very distinct at this point. Anyway, at this point that's going to be about it. I can't really go any higher without endangering myself, so I have to thank you for joining me, and hopefully I'll see you again soon when I do have some shielding. Thanks for joining. See you again sometime later.